Okay, so in previous videos in this channel, we have talked about the sine rule, and we even went as so far as to prove the actual sine rule. Now, this was the proof we came up with in these previous videos, that a over sine a, so a side over the sine of the angle that's opposite it, equals another side b over the sine of the angle that's opposite to that, is equal to the third side over sine of the angle opposite that one. Now, what we didn't talk about in those videos was that this was the case for acute triangles. This also works for right angle triangles, but we haven't really explored how this works in what we call the obtuse case. So when we have a triangle that looks something like this. Now, in order to approach this question, it works slightly differently in terms of the other triangles. Because of this kind of acute angle, this obtuse angle here, it becomes quite problematic. So we have to extend outside of this actual triangle and apply some of the things we learnt in non-right angle trig and the unit circle as well. But before we do anything, we're going to start this question off how we normally would. Okay, so we would draw. We said that our sine rule works in the way that if we break up this non-right angle triangle into two smaller right angle triangles by drawing this perpendicular line, I'm going to call this height h1. We notice a couple of things. Now, in this triangle, we're looking at angle A and angle B as well. Now, working through really quickly, because this is basically what I did in the initial video when we proved the sine rule. We said that sine of my angle A over here equals to h1 over the side B. Opposite over hypotenuse. This is just the basic trig that we've talked about previously. Rearranging this equation, we multiply b to the other side to get h1 on its own. We get this particular thing here. Now we can do the same thing with our angle b. We're going to say sine of my angle b equals to h1 opposite over my hypotenuse, which is a. Rearranging this gives me a times sine b equals to h1. Now, we made this connection as well, that since these h's are the same, because it's the same length in both of these smaller right angle triangles we've made, we can set the left-hand sides of each equation to equal one another. So we can say, therefore, that b sine a equals to a sine b. Now, rearranging these two equations, if I divide both sides by a here, that's going to give me b sine a over little a equals to sine b. And then dividing both sides by b here is going to get sine a over a equals to sine b over b. Now, this is the first part. We've related two of these right angle triangles together. Now, please note as well, we talked about this in the video where we proved this. Sine A over A equals sine B over B is exactly the same as the sine rule that I've written up here. It's just the numerator and denominator are flipped. So it's just two different ways to write basically the same formula. Now, that's cool, but we've done this in the same way that we have previously. But the problem is, if we look at this picture, because it's an obtuse triangle, there's no way we can cut this up to work with this angle C here. Because it's obtuse, we can't really draw up a perpendicular line like we would normally. So we have to now think about moving outside of this particular obtuse triangle. So what I'm going to do, it's going to look really kind of weird here, but let's actually make this the same color. If I draw out here and then down to here, I have made a right angle triangle. If you kind of look at it, I've drawn it in here to here to here. I've made a right angle triangle. And I'm working basically outside this obtuse triangle that I have ABC. Now what I'm going to do, I'm going to give this side a new name because it will help for our angle notation when we're writing out the angles. Let's call this side, apologies. Let's call this section here angle D. Okay, so what we are going to do is we are now going to consider this other right angle triangle. So I'm going to be relating, because remember with sine rule, we want to relate the angles to some other angles we have. So we've proved half of it, the sine A over A equals sine B over B. So we want to relate sine B over B or sine A over A to this C here as well. Now, by drawing this in, I have a new acute angle with C, this pointy end, over here. And I'm eventually going to relate that to the obtuse angle inside here. But I'm just going to consider basically these two triangles. ADC and a triangle ADB. This larger one over here. So I'm going to say in triangle ADC. Now, I haven't really given this height a name yet. Let's call this extra height that I've drawn in H2. Now, I'm going to say that sine of this angle ACD, this one here, equals to H2 over B. So I'm going to write that in. So sine, let's do that in the same color. Sine of angle ACD equals to H2 over B. Cool. Now I'm going to rearrange this. I'm going to say B sine angle ACD equals to H2. And then I'm going to talk about this triangle over here. So my larger one. So that was my triangle ADB. So I'm going to write here in triangle ADB. So this larger right angle triangle I've made. My sine of B, my sine of ABD, which is the same as this angle in here. So that one there, sine of B, is, I'm talking about the same angle over here. So I'm going to write sine of B, because ABD, for example, the angle there, is the same as my angle CBA, for example. I'm still looking at the angle down here. So I have set that out down here. So sine B is going to equal my H2, my opposite, H2, over my hypotenuse C. And I'm going to rearrange this formula where it tells me that C of sine B equals to H2. Now, what we're going to do is we're going to pause for a minute, because you're probably looking at this and going, well, cool, we've related our sine rule for this angle out here, this guy over there, and this one in here, but I still want the obtuse angle, right? I want this one in here. That's my angle C in this obtuse triangle. So we want to make a link between the angle ACD. So let's actually do this in another color so you can really see what I'm talking about. We want a link between this guy here, angle ACD, and the angle ACB, this one over here. Now to do this, we have to consult some unit circle trigonometry. And this is a trigonometric identity that the sine of a particular angle is equal to the sine of its supplement. 180 minus theta here. So we talked about this in unit circle trig. There is a reason why this works, but sine of any angle is the same as sine of 180 minus that angle. This is a trig identity for supplementary angles. So by that identity, ACD, this angle on the left, is equal to ACB, the angle on the right. So I can basically replace that in here. Let's actually do another page. Let this load for a minute. But my angle in here, this guy, is the same as angle, well, we've talked about ACB. So I'm going to rewrite both sides down the bottom here. So B of sine ACD equals to H2. Now ACD, if I look at my most general obtuse triangle for my sine rule, that we're just going to call angle big C over here. So in essence, we can write here B sine C, because remember, this is the angle, my original angle that I wanted to relate back, equals H2. And on this side, I still have what I talked about before, which was that C sine B equals to H2. And now we're going to do that exact same trick that we did before. So H2 and H2 are both the same. So I can set B sine C to equal C sine B. And I'm going to just divide it through in the same way. So I'm going to divide both sides by C here. This gives me B sine C over C equals to sine B. And finally dividing both by B, I'm going to get sine C over C equals to sine B over, that looks like a D, let's make that clearer. Because sine C over C is equal to sine B over B, sine B over B also equals to sine A over A, so we can say now, therefore, sine A over A equals to sine B over B equals to sine C over C. It works in the exact same way as our regular sine rule. The only difference now is that because I have an obtuse angle that I have to work with, I have to look outside my regular obtuse triangle. So if I get rid of all of this extra information, we can see that it works in the exact same way. Where I have my angle C here, and taking this part away, I still get that sine A over A equals sine B over B equals sine C over C, or A over sine A equals B over sine B equals C over sine C. These mean the exact same thing, they are just flipped around. This is how we can imagine sine rule in the obtuse triangle case. It's a lot more complicated because of this obtuse angle, proves to be very problematic, but with a couple of trig relationships that we learnt before. So if this part was a little bit confusing to you, please look back at the video on unit circle trig. But by extending this out and with our proofs in a similar way, looking outside of our triangle ABC, we can still arrive to the same conclusion as in the acute triangle case. Thank you so much for watching, and I'll see you next time.